Good evening, everyone. I'm Mafinar Khan. I recently joined Planswell as software developer, and today I would talk about a backend developer's experience in GraphQL, and along the way, I will discuss about my experiences with it, from very novice experience to 1 year later experience, and also the kind of patterns and practices that I picked up along the way. So this talk will be in basically on 3 parts. At first, I'll talk about the project that I started GraphQL with, and some history of it, and then the normal backend workflow when you're working with GraphQL, like regardless of languages or frameworks, and finally a code organization practice that I followed in 2 of my projects. I've been working professionally with GraphQL for 2 years now. And but I won't talk about any of the projects that I've been working with currently or before, but one planned open source project that I was working with a couple of my friends, which has been in the works for a while, and I started working with with GraphQL and React from it, and I would walk through the whole backend process. So, first part, the history of the project. So I would talk about vehicle tracking system. We started working with it on 2014, and it started off as a Django project. It started off with AngularJS, and then React came and we started working with that. The database was Postgres and CouchDB, and some Redis and Twisted was used. A little bit of features. So the app is like, think about, let's say that you own a fleet, or you own a car, or your son owns a car. So you can track it, and at the same time you can get some real-time reports, get some geofencing reports, and at the same time you can have authorization systems. Like if it's an office fleet, then the HR manager or the sales manager can track all the vehicles that are used by the marketing or sales team. And there are, like, if your car ever gets stolen or if it's lost, you can like send an SMS and log the vehicle. You can take pictures of whatever inside that car. So these are the features. And technology-wise, so we use several devices. We planned on using several devices. Each of those devices will collect data from the satellites, the GPS data, and send it to a TCP server, which was at first a Java and native-based server, and then we moved on to Python and Twisted. Different devices have different capabilities. Some devices allow you to take pictures. Some devices allow you to stop the engine, log the cars. So, and also they have different protocols. And the real-time data, whenever the device got the data, the data was stored in a CouchDB database, and the last data, like a scoreboard, was stored in Redis. And all the business information about the vehicles, the users, the owners, the groups and subgroups, all those things were stored in a PostgreSQL database. So you can see that there are lots of stuff at play here. But at the end, like, different layers talk with each other, but the end communication what the user saw was a React application, initially using REST. And we were somewhat happy with REST until GraphQL got our eyes. Like, we're like, okay, so since it was a hobby project and it was supposed to be open source anyway, we're like, okay, we can take risks. We don't have any timeline or something, so let's use GraphQL and see what it's about. We were already impressed with React, and so since the same company got it out, so we thought, okay, maybe it's gonna be worth a try. So we started off working with GraphQL. We didn't quite know what it was, and back in 2015 or something, when the GraphQL paper came out, I'm pretty sure it took a little time to get used to what GraphQL exactly does. Like, what is it? Is it like something that magically gets you all the data in a different format? Or is it something like REST, or what is it all about? So I'm pretty sure you all know this definition. So it's comprised of a query language and a server-side runtime. So I will mostly talk about the backend and server-side runtime in this one. So first reaction was, okay, so when we're using Postgres, like PSQL, we give it a URL and we give it a password and username, and then we write SQL commands and we get the data back. So is GraphQL kind of like that? I mean, is it like we're just giving it a URL and then we can query the data and get the data back? So it's like a Postgres console for the JavaScript developers. It's kind of true, but not entirely. So the first reaction for us is like, okay, this cannot be secure. Like, how am I accessing the data from GraphQL from just like that? And that's before we tried it out. And then it's like, okay, so would all my REST API translate one-on-one with GraphQL API? So just a bit different ways. So why do we have a separate mutation? Why not just have, like, say you have a vehicle and then you add a new vehicle, just say use it as a query, so that makes you better readability, right? I mean, you have read and write kind of a thing, and you're also allowed to do that because GraphQL doesn't know whether you're writing in a database or not. And then, like, how do I translate my database into a GraphQL schema? So those questions came out, and then we actually tried out, and on the first week we translated our REST API endpoints into GraphQL queries and mutations. I was like, it wasn't how it's supposed to be. Like, just because something works, like there's a term like, you can write Fortran in any language. So you just cannot make REST API in GraphQL or anything else. So that was that worked, but we were not quite happy with how it turned out. It's like, okay, it's a GraphQL, so what's so special about it? Next week, so we learned a little bit, we saw some talks and had some chats, and then here, okay, so let's just have a GraphQL, let's do something else. Let's translate all our Django models into GraphQL. So if I have a client with first name, last name, date of birth, the GraphQL would have the same thing, and they should have the same name. I mean, we did not really get out of the whole active record thing. So again, that did not work. Then we realized, okay, so GraphQL is not REST done differently. It's not a fancy collection of, like, it's not like, okay, your GraphQL schema has nothing to do with database or anything else. Or you don't even have to think about the database when you're designing your GraphQL schema. And it is a completely different way to think about your data, because before that, our brains were used to relational database, and REST didn't quite help, because no matter how REST says about resources and other stuff, most of the time you end up mapping your database as a REST resource, whether it's a good practice or not. A lot of people get away with it. So not that. So we then we ended up thinking in a different way, and we finally got that out, because it's not the same way you think of it. You talk with your front-end developer, your backend, you talk, everyone sit on a talk, you communicate on how the data you want, regardless of whether that field exists in the database or not. Just talk about how do we want the data shape to be when we are designing the front end. And then go back, design the schema. Design the schema not thinking about the database or anything, design the schema how it's expected to be. And then you try mapping the database calls or everything else. If there is a problem that you cannot get out of, have another meeting, change the schema shape. That's rare, but if you need to, change the database and then come back. So the dominant factor of the communication is not about how the architecture is like. It's about how you want the front-end architecture to be like. And if there is something too different that you cannot do at all, that's when you change it a little bit. So here's an example of a query that we finally came out with. So here we have a vehicle. You get an ID back, you get the geofence status back. Geofence is like if your vehicle deviated from the polygon that you drew on the map. And there's the history and last location, device features. So in one go, I can get all of them. And when I receive the query, this query alone has multiple data sources, like history comes from CouchDB, last location comes from Redis, device features and all the other like IDs and vehicle IDs, they all come from the Postgres database, which was added from the Django admin panel. And in this way, we were forced to think in terms of how we want the data to be like, how we want the front-end data, or in other words, the client data to be like, as opposed to how, like, the whole communication is geared more towards the end user of the API, which should be in all the cases, but in GraphQL, that's kind of out there in your face. So the first thing is that the mindset should always be from the perspective of the client. And the mutations were similar. So when we stop the engine and when we take a photo, these commands actually translate into a Python code which connects to the TCP layer of the machine and then sends the command after parsing to the device's format, and then it gets returned. In between, all the logic takes place as to like what device is using, what the protocol should be like. There's a dictionary for protocols, it matches. All those logics do not know that they're participating in a GraphQL resolve. They just do what they're supposed to do, and the other side, the API resolves it. So the APIs, there are a couple of things, a couple of nuances in GraphQL. One is IDs. Like every mutation returns something, but you got to make sure that you're returning the ID, and also it should be packed. Like that's a good practice, that you should pack your results as a payload as opposed to sending raw stuff from the mutation. And queries, also the inputs are of the same way. So now the backend workflow patterns. So I guess this is quite a popular thing. Like this is a different rest than GraphQL. In GraphQL, there is just like when you're using a console for Postgres or Redis, we just give the URL once, and then we keep on going back and forth with commands. GraphQL kind of works similarly, that you give it the URL once and then manage everything with the multiple URL hits are hidden from the client programmer, because she's just changing and calling the patterns. So normally, although I work with, for this project I work Python and I work with Go and Elixir as well, I'm going to limit this, I'm going to be fairly programming language or framework agnostic when I'm defining things. But this is the common pattern of, regardless of what language you use, this is the common pattern it uses. Situation, you already have a backend system and you want to implement GraphQL. The first thing you do is, obviously, if it's a React or Angular or whatever the front-end developers are working with, you bring in a meeting and you discuss about what do they want, how do they want the whole system to be made, and then after that come up with a shape of data. Just keep in mind about some logics like the ID thing and the package and the input, and those are the rules, and then come up with a common schema structure, and then go and start working with it. Go and start working with how you're going to design the whole thing, and then come back and do this iteration a couple of times until you come up with a solid schema and query structure. And then you have a structure, so almost all the languages have GraphQL parsers and stuff, and even if they don't, it's just an API call, so it's a different thing. So you use a parser, and then it's your time to map with the business logic. So user first name last name gives you first name and last name. That's what GraphQL expects, and you create a GraphQL schema that maps with that output. But now you gotta create the Python or Go or whatever other language you're using, that code that actually does that, and then packs those data into the schema type and return it. So pretty much in all the cases, this is the pattern. You create a schema type using struct or class or records, whatever you have, and then define the queries. And those queries should have a resolver that goes on and changes the data or fetches the data. And if you have an authentication, that can also be maintained within the resolver. And if you have any post-processing or pre-processing, those can be done with middleware, because those are functions which you can intercept it before or after. So in other words, basically the steps are, first of all, you have the URL, then you have the schema design, you have a serialization method, and pre or post checks, and then you have some resolver functions, and then the domain logic. And although there are lots of automatic stuff, like they can translate your tables automatically, but it's like if you're designing an API and if you know what you're doing, so you know what you're doing, so it's better to handcraft all of those things. That's my opinion. There are lots of tools in GraphQL. There is the built-in GraphQL. There are lots of middleware that in Python, in Django, for example, there's a middleware that hooks in debug toolbar, and whenever you call something, you add that extra query, and it gives you a number of database calls that were taking place while you're bringing in the query. So there are lots of other stuff, so it's better to use them as long as you're using it in dev mode. So the code organization practices. This is where I'll go very opinionated, and it's not necessarily the right way of doing things, but that's how I organized my source codes, whether it's like Go or Elixir or Python. Okay, so what I believe in doing is that every module that you use, they need to be within a context. So like if it's an MVC pattern, I prefer my controllers only do controlling, like they only get the request and give the response. They should not be doing any kind of data processing or anything. They should call something else, some other function, which are solely for those purposes. And so after a lot of iteration, the final way of doing things were that in my backend code, I created a separate module entitled GraphQL, which is like a plugin coming in of it, and then it only is responsible for GraphQL kind of things. That had two parts. The first part is lib, and the other ones, it could be web or API or whatever. The lib portion, it only contains data, like a function that takes in a specific shape of data and gives out another shape of data, and then all the business logic that needs to be performed. It does not know that it's going to be called in the context of a GraphQL. Even if you code it from the shell, you can just have results coming in. So if you have a stop engine method, there will be a stop engine function that takes an ID and then queries the database for the ID and gets a special, the magic number, and then queries back into the magic number and queries the TCP server and sends it and pings that ID, and then queries the device type of that vehicle, gets the protocol, maps it, packs it to a string, sends it to TCP, stops the engine, upon receiving OK or not OK, gives it back. So even if you call it from a shell, even if you call it from, like just call it in another separate program, even if you call it from a Django model, or it doesn't matter, it will do the same thing. The second part, there's a serializer. It sends OK, but the GraphQL mutation that we're expecting, that would have a separate data signature. So serializer would exist to translate that results coming out of that domain logic method and packs it in a GraphQL and then returns that GraphQL schematified version. So serializers do only that. Take in Python, take in the native code, take out the GraphQL version of that native code, and the opposite. And finally, the GraphQL API. The GraphQL API will be consisted of resolvers, queries, and mutation. Resolvers usually would hold the same signature as probably the domain method, but you will have additional stuff like the GraphQL context, information which can contain the GraphQL paths and stuff. And then only thing resolvers would do is call the domain methods, get the authentication information, like take out the user information from the info, plug it in on the authenticated method, get the authorization rules, and according to the rules, either call the domain function or just send an error message just an error message. And queries and mutation will map with the structure, which will have the types and its resolvers. So these are basically, I forgot to change the path, change the slide, but basically what I said is also explained more here. So one other thing is that there can be middleware, like a resolver can have middleware which would intercept something, like if you have if you want to create a debugging app which takes out the, like Django debug toolbar is this, it takes out the functions and translates the SQL, explains it and sends it back. So if you want to do something like that, or if we want to add the page ranks, or like who visited what or who did what, those kind of stuff, you can always use middleware for it. So again, so after we're done, so this model of file structure has some good stuff. Like the first thing is that if we, in future, if you want to update the GraphQL, if we want to add something new to our schema, what happens is that when we're adding something to the schema, we know where to touch. We touch the schema file. So if the schema gets added, that will have an additional resolver, and then we go and add the resolver, and then we go and add the related function logic behind it. So, and since GraphQL only asks for what you need, it doesn't really affect as much as their REST counterpart would be for V1 and V2 stuff. So that's one thing. The other thing is, let's say that after a while I decide that CouchDB doesn't work for me. I want to move on to Cassandra. And the TCP server, we have a lot of vehicles. Now I need a message queue or something, and then take it from there. So for those things, that doesn't concern the GraphQL, because for GraphQL, I'll always be last location, lat long. That's all I need. So all I need to do is go to the domain model and then change the logic over there. As long as the input shape and the output shape are the same, it doesn't really matter. I won't have to touch the resolvers or the GraphQLs. So that logic, that context, that would be limited to that. Also, each of those systems can be separately tested. I can test and benchmark each and every of those modules separately. So this is an example. This is an example of a very small snapshot of that. So API was the root model. So lib/vehicle/context, it had all the logic for reads and write. So there are device inventory, vehicle, user, and authorization. Each of them have separate submodule, and they all have their context and all the other stuff that communicates to the database, writes to the admin panel, fetches from the database, and all these other things. And then the serializer. Serializers convert the Django domain model, Django active record model, into the schema types. And then types, and these are the two main functions of the non-web part. Inside the web part, there are like types, resolvers, and queries or mutations.py. Types define types in a schema format. Resolvers, usually a lot of languages have types and resolves packed together, but I prefer to keep them separate. Resolvers just do the stuff that web stuff do. If there's some caching to do, or if there's something throttling or anything else, those can be done in resolvers, but it will only do whatever is done, it needs to be done in the HTTP context. And they can only call the lib. There should be no other imports in resolvers. And then the queries and mutations.py. So this structure .py could be .go, .ex, or God forbid .js. So now about the code. Wait for it. So actually, I'm working on removing some of the stuff and open sourcing it. So everything that I said in that way, I would open source it and share it in the Slack or Meetup comment so that we can use it. So basically, all I said, this structure is followed over there, and we're also working on an Elixir version of it. So there can be just two open source things. That's it. Backend for GraphQL. Thank you very much.